This is such a cool question because this actually is a way to prove that for a generic n, what this limit will be equal to using L'Hopital's rule. Because, the first thing you do is you always plug in, and when you plug in here, you get 1 plus 0 quantity to the n power minus 1 over 0. So that gives us 1 minus 1, so 0 over 0. Now, we talked about in a couple questions ago how, like if you get a 0 over 0 situation, you can factor, cancel, and plug in. But when you look at having this n power, there is no way you're going to be able to factor this out so that you can get that x to come out of that numerator and out of the denominator. So this factor cancel plan is not going to work for us. And so that means that L'Hopital's rule is going to be required. So remember with L'Hopital's rule, it's basically a two-step process at this point. You take the derivative of the top and you take the derivative of the bottom. So I'm going to look at the limit as x goes to 0, and then here I'll use the general power rule because I have parentheses to a power. So I bring down the n, 1 plus x to the n minus 1. And again, that's just bringing down the n, subtracting 1 from the exponent. If you look at the derivative of the inside, you see that that is just 1. The minus 1, standalone constant, goes to 0. So then in the denominator, if I take the derivative of x, I just get 1. So after I take the derivative of the top, derivative of the bottom, then I kind of reevaluate things and I plug in to see if any progress has been made. So in this case, I'm going to plug in 0 for x. So x is equal to 0 is what I'm plugging in. So n is just going to stay as n, 1 plus 0 to the n minus 1 over 1. So what's so cool about this is that this 1 plus 0 to the n minus 1, 1 to any power besides 0, 1 to any power is going to be equal to 1. So we're going to have 1 times n over 1 limit as x goes to 0. So we have the limit as x goes to 0 of n. Now, in the context of this particular limit, n is a constant. So this is the same as like the limit as x goes to 0 of 5. You would not blink an eye there. You would say, okay, that's a constant, so that limit's equal to 5. That's the same thing that's happening over here with this n. It is a constant. It does not depend on this x. So this limit will be equal to n. And so using L'Hopital's rule, we were able to show that the limit is equal to n. So that is such a cool question because it really allows us to see an application of why we care so much about L'Hopital's rule.